Welcome back, geometry students, to 3.4. If you struggled with 3.3, then I suggest you go back and maybe rewatch the video. Maybe write down a few things that you might have missed, because those are very important topics and those are very important concepts, because they feed into what we're going to do here, and those are going to play a big role in what we call doing proofs. Okay, so proofs are one of the biggest pieces in all mathematics, and it's what most professional mathematicians, yes, professional mathematicians do exist, spend their time doing. Okay, they have to prove, okay, certain things based on information that they're given. Okay, and we don't try to get too exotic, but basically a proof is taking given information and then using that given information plus any knowledge that we have previously and trying to form a conclusion. Okay, that's kind of what a proof is. You're trying to take the given information, you're trying to add on your knowledge, what you've learned so far, and you're trying to kind of go for a specific conclusion. Okay, let's kind of take a step back here and think about the different ways that we have to prove triangles are congruent. So if we look at number 4 here, we have side, 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 and side, side. So our congruence, yes. And so S, T, U. So now we got to look what matches up with S. Well, I'm going to probably say V. And then I go down here to T, so I'm going to go over here to X, and then back to W. And my reason for that is going to be side, side, side. Okay, that's going to be my S congruence. Okay, so side, side, side is our big one here. Number 6 here, and you can ignore the numbers, these are just examples. So let's see, I've got this side and this side are congruent. This side and this side are congruent. So I've got 2 sets of sides and 1 angle. Okay, and that angle is in between the 2 sides. Okay, that angle is in between. That angle is what we call included. So yes, those 2 are going to be congruent. C, D, E matches up to, let's see, C matches up to F. D, this right angle matches up to G. And E matches up to H. So, and my reason is going to be side, angle, side. And notice how that's written. Remember that the angle is in between the 2 sides. So that's my SAS. So over here, number 20. So I've got this angle, and then this angle, and this angle. So I've got 2 sets of angles. And then remember that this is part of both triangles. Okay, so I've got 1 set of sides, or one literally side. So yes. So if we go S, T, V, that's going to be congruent to U, V, T. Okay, so this S matches up to U, and then I go down to V, and then back up to T. And because I have 2 sets of angles and the included side, that'll be my angle, side, angle. This one's a postulate, but if you just said ASA, you would be fine. Okay, so now we're on to our last one. So here we have, well, let's see, based on, I've got this angle, and then this side and this side. So right now I've got 1 set of angles and 1 set of sides, but please notice that those 2 are vertical. Those two are vertical angles. Vertical angles are always going to be congruent. Okay, vertical angles are always going to be congruent. So I really have two sets of angles and one pair of sides. So congruence is going to be, yes. So WXY is going to go with AZY. And my reason for this one, just based on where things are located, okay, is going to be angle, side. Okay, that's angle, side. Remember, that was the one where you go angle, next side, angle, next side. Okay, kind of going around the triangle. Okay, so you need to be comfortable and familiar with these four. Okay, those play a big role. So now when we start to look to prove things, let's look. How do proofs work? Okay, so this is an example using side, angle, side. So now let's look at what we've got here. Let's look at what we got. So we're given some information. Okay, so that's kind of what our first statement is. Our first statement is usually the given statements. Here they put both into one statement. You could have just easily said, hey, 1 and 2, if you wanted to do that. So let's see what they say. They say N is the midpoint of LW. So N is the midpoint. N is also the midpoint of SK. So then you're trying to prove that the triangles are congruent. Okay, that seems workable. That seems workable. Okay, so let's look at what our statements are. Okay, what does it literally mean to be a midpoint? A midpoint means that you're exactly in the middle. Okay, so what my next statement is, you know what? If N is a midpoint, then this is congruent to this, right here. I'm also going to say Sn, this part right here, is congruent to this part right here. Okay, and how do I know that? Well, by definition of midpoint. If you are a midpoint, that means you literally cut two things in half. Okay, you literally cut those two things in half. So we start with our given statement, and then what is the result of my given information? Okay, what is the result of my given information? So then I look around and I'm like, wait a moment. These two angles, they're vertical. So I can say, you know what? Those two statements are vertical. Vertical angles are always congruent. Always. So I can say that anytime I've got vertical angles, and it might be helpful. So vertical angles are congruent. So now, based on this and this, if I look at my triangles rather, I've got a side. I've got a side, an angle, and a side situation. So my statement becomes, hey, yes, those two triangles are congruent by side, angle, side. And my last statement is what I'm trying to prove, okay? And I must give a good reason for that. Some kids would write just, proven. That's their final statement. So if you ever find yourself doing that, you need to stop, because that is not an acceptable reason, okay? And likewise, some kids give me a reason like because it looks like it, because of the picture. That is not a reasonable reason, okay? You've got to think about, what kind of ideas, what kind of topics am I talking about? I can't just say, oh, it looks like it, or I can't just say, oh, it's proven. That doesn't give me anything. You have to make a logical, mathematical argument. That means you have to think some things out. Okay, so let's look at a couple here. So here, you're given two things. S is congruent to U. Okay, so we're going to say S is congruent to U. And you're given that SP is parallel to OU. Okay, SP is parallel to OU. Okay, so what's it mean to be parallel? All right, so parallel gets me a few things. Now, if I look, If these two are parallel, then I'm going to say SPO is congruent to UOP. Why can I do that? Well, this goes back to like Unit 2 stuff. If I've got two parallel lines, okay, and a transversal, these two angles are going to be congruent. Okay, those are alternate interior angles. Okay, so that's what I say. All right, SPO is congruent to UOP by alternate interior angle theorem. Okay, if I have two parallel lines, then they're going to be congruent. Now, pay attention to this next step. You see how OP is parallel, or is part of both triangles. Not parallel. It's part of both triangles. Okay, I have to say that OP is congruent to itself by what we call the reflexive property. Anytime you have something that is part of both triangles, you're going to have to use this. Okay, you're going to have to use what's called the reflexive property. Basically, it just says that you're equal to yourself. Okay, that's all that means. Okay, you just have to say, yes, that's going to be equal to everything. That's going to be exactly what it is. There's not going to be any more or any less. So now, once I've said those things, then I've got alternate, or not alternate, angle next side, angle next side. So my final statement is proof, is what I'm trying to prove. And by what reason? Angle side. Okay, let's look at some here. So now, let's take a look. So I'm given PQ is congruent to RS, and PQS is congruent to RSQ. So my very first things here are going to be PQ congruent to RS. Why? That's given. Second statement, PQS congruent to angle RSQ. Okay, so let's talk about for a moment, what are we given? What are we given? We're given that PQ is congruent to RS, and we're given that PQS is congruent to RSQ. So that's given information. It's given information. Okay, so I'm given kind of one set of sides and one pair of angles. So now if I think about ways to prove things, so I've got side, angle, side, angle, and angle, side. These are my ways to prove. Okay, so I can kind of look at, okay, I've got one set of sides, one pair of angles. So that kind of eliminates side. Okay, that eliminates side. So I'm kind of looking for one of these three situations. Okay, so let's look. They kind of give us the next statement. QS is congruent to QS. Well, that's exactly the same. And if I look, QS is part of both triangles. QS is part of both triangles. So remember, when you're part of both triangles, you do what's called reflexive property. Okay, and that's it. That's all I need to say. The reflexive property says, yeah, you're part of both triangles, and you're equal to yourself. So now I'm given another set of sides. So I don't have one set of sides anymore. Now I have two. So two sets of sides, one pair of angles. That means I have to use side, angle, side. So I do a check. Is my angle in between my two sides? Yes. Then my final statement, not A, B, C, D, B, C. This one's correct. PQS, RSQ. Yeah, those two triangles are congruent by side, angle, side. That's what I'm trying to do. That's what I'm trying to do. Look at the information plus any knowledge I can pick up and try to arrive at my conclusion. So now here, this one's very straightforward. Very straightforward. Okay, so AB congruent to DE, they give you that statement, and that's a given. They also tell you AC is congruent to DF. That's a given. They also say BC is congruent to EF. That's a given. Okay, so just from the given information, So that says prove, by the way. I'm sorry about that. So just from the given information, you're given sides, and a third set of sides. So you're given all sides, no angles. All sides, no angles. So anything with an angle in it that I'm trying to prove is out. So I'm using side, which is what I want here. So my final statement's going to be, yeah, ABD is congruent to DEF. That's all I'm doing. That's all I'm doing. Okay, that one's pretty straightforward, easy, that one. Let's take a look at a couple easier ones, or a couple different ones. So here you have AE bisects BD, and that's a given statement. And then you have AB is parallel to DE. So which is indicated here by the double arrows. So now let's look at what this says. AE bisects BD. So AE bisects BD. So what does that mean? That means, what does it mean to bisect? Bisect means cut in half, right? But now relook at the statement. The statement says AE bisects BD. Okay, so what gets cut in half? Well, BD gets cut in half. So BD gets bisected. So my next statement, BC is equal congruent to DC. That's a direct result of this first given statement here. That's a direct result. Okay, so what do I write for a reason? Well, I know that that's true because it gets bisected. BD gets bisected. So I just have to say definition of bisect. That's a definition of bisect, is to means to get cut in half. Okay, that's all I have to say. So now let's look at this next statement. ACB and DCB. I think that's supposed to be DCE. ACB, DCB. Okay, ACB, DCE. I'm hoping you recognize those as vertical angles. So all I have to say is vertical angles are congruent. So now let's look at what I have here. Okay, so I've got one set of sides, or one pair of sides, and one pair of angles. Okay, so I'm down to side, angle, angle, or angle, angle, side. Okay, side is out. So now what would be helpful here? Well, what would be helpful is knowing that these two are parallel. And this is kind of a long-range thing, but I'm going to say angle B is congruent to angle D. Okay, I'm going to say angle B is congruent to angle D, okay, by alternate interior. Okay, so if I kind of want to think about this, I have parallel lines and a transversal cutting through them. So I'm saying this angle is congruent to this angle. This angle's like B, this angle's like D. So now I've got this. So let's look and see what we have. So what do we have? So we have angle, 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 side, side. The side is in between. So that's going to be angle, side, angle, and that's what I want. There's my answer. Triangle ABC, triangle DCE. That's what I'm trying to prove. Okay, let's move on. So now we have nothing. So now they've taken away all my help. Well, let's see what we can do without it. So my first statement, PR congruent to TR. That's given. And they noted that for me, which is helpful. Number 2, angle P is congruent to angle T. That's also given. Okay, and they also noted that for me, which is nice. So now they don't give me any other information. So this is where I have to look and see what other information I can kind of glean from this. So if I look, I need to notice that, look, these two are vertical. Those two are vertical. So that's what I'm going to say. I need to say angle PRQ is congruent to angle, not triangle, sorry, angle TRS. And why can I do that? Well, those are vertical angles. Vertical. Apologies, spelling is questionable today. So vertical angles are going to be congruent. So now let's check and see, do I have enough to prove my triangle is congruent? Well, let's see. I've got two sets of angles. I've got a side in between. Yes, I would argue yes. So final statement, ABC congruent to DBC triangles. And that, for that reason, is going to be angle, side angle. Okay, that's the postulate. Okay, so I'm hoping that you're at least getting an idea of a way to frame your proof, a way to at least set up your proof, kind of get an idea. But you have to bring in some thought. You have to bring in some thought. Okay, so this one's got a little bit of a challenge to it, but it's not nearly as bad as you think. Okay, so now let's look. So let's look. So let's set up our proof. So I make a bit of a T-chart here, and I start with given statements. So C is midpoint of AE. And that's given. Then I say, next given statement, BA is congruent to DE, given. And number 3, angle A is congruent to angle E, given. Okay, so they marked off the second one and the third one for me. Okay, so now let's look around and see what else I can kind of get off of this. And I'm looking at the very first given statement that C is the midpoint of AE. And I'm remembering back to that previous one where, well, what does it mean to be a midpoint? Midpoint means it's exactly in the middle. Okay, so based on that, C is a midpoint of this segment, A to E. So what I can say then is that, you know what, I'm going to say AC is congruent to EC. By what reason? Well, that's just definition of midpoint. Okay, that midpoint literally means I'm cutting that in half. So now remember, I'm trying to prove triangles are congruent, and I'm going to argue that I have that information now. Okay, so my final result is going to be this: triangle ABC is congruent to triangle EDC by side angle side. That's going to be my reasoning. Okay, now this section, both parts, okay, they require some thought. They require, you might make some mistakes. You might have to go back and try again, and that's fine. That's fine. This is how we learn. This is going to take some time to get used to, and writing a good proof is a skill, and it's something that takes practice, and it's something that you might have to think about and kind of roll over in your head a few times and until you kind of understand what you're trying to do. Okay, so good luck with that, and I look forward to answering your questions.